observe today.
Oh, perfect.
Yeah.
Okay.
Yeah, absolutely. Come on in. There's space in the back over there. Thanks.
Okay. Okay. So logarithms, right? First thing we have to learn how to spell it, right? Log a rhythm. Okay, logarithms. All right. So this may be the first totally new topic that we have talked about this year for most of you, okay? Logarithms are inverse exponential functions. Okay? So many, or not many, all of the properties of logarithms should look familiar because it's basically the same as the properties for exponents. Okay? So the first thing I want you to do is put your iPad away if you have your iPad out, Alex. And Alex. Okay, still remember our new rule this semester, right? Taking notes on paper. You might have been absent, actually. Sorry. Okay, so what I want you to do is I want you to take a whole separate sheet. You can use a separate page in your notebook, the back of divider. You can use the inside of your cover. Separate page that you can easily find. Because I'm going to give you a list of properties. You need to be able to refer to those properties quickly. Okay? So we're going to do this for logarithms, and then when we do trigonometry, we're going to need a separate page too. These need to be on a separate page from your notes. They have to be found easily and located easily, okay? So the first thing we're going to do is an actual definition of a logarithm. All right? So the definition of a logarithm says that if log base b, we use b so that we can remember it's the base, log base b of x equals y, if and only if, and we're going to talk about that in a moment, okay, if and only if b to the y equals x. Okay, this is very important. This is our definition of a logarithm. We will refer to this about a bazillion plus 2 times. Okay, the definition of a logarithm, right? So like we just talked about, I know that you can go on your phone and you can quickly find this definition. But it's meaningless, right? There's an example of being able to find the information. You can have the information at your fingertips, but you need the wisdom to be able to actually use it, okay? So in order to be able to use this, we have to know it. We have to understand it, okay? All right, so let's talk about that phrase, if and only if. So we can go back to our notes now, right? This is on the separate page, this definition. Let's go back to our notes. Okay, this if and only if here. Basically what that means is that this goes both ways. Okay, in math, there's 2 symbols that we use this. We'll use IFF instead of writing out, because in math we don't like words, right? We try and use as many abbreviations as we can, right? If and only if. And then sometimes you'll see it as like a double arrow. I actually like that because that is more clear to me. That means it implies both directions. Okay, so we're implying both directions. So that means if I see it in the form of b to the y, if I have an exponential function, b to the y equals x, then that implies that log base b of x is equal to y. Whoops. Equal to y. Okay. Here's an example of a logarithm. Log base 3 of 9. Okay, notice how I said it. We have to say it like that. Don't read that as log 3 9. It's log base right? The base is on the bottom, right? That 3 is down the bottom. Log base 3 of 9 equals 2. How do I know that log base 3 of 9 equals 2? Well, I know that because according to the definition, if this is true, then 3 to the second is equal to 9. Well, does 3 to the second equal 9? Yes, it does. 3 to the second equals 9. Therefore, I know that log base 3 of 9 equals 2. Remember, logarithms, what was the first statement I said about logarithms? They are what? Inverse exponential, right. Inverse exponential. This is exponential right here. Here's my exponential function. Here's my logarithmic function. Okay. Logarithms are new, but they're not particularly difficult. Okay, you're going to recognize things that are very, very familiar. Okay, so using that same definition, can you tell me what log base 5 of 125 would equal? Log base 5 of 125. Jackie, what do you think that equals? 3. Why do you say it's 3?
Because 5 to the third is 125.
Excellent, because 5 to the third equals 125. Very good. Okay. How about, let's look at log base 2 of 16. Log base 2 of 16. Mika, what do you think? 4. Why is it 4? There you go. It's 4 because 2 to the 4th equals 16. Who has a question about that? How about giving me a fist of 5? Okay, good, excellent. Okay, well, here's a more challenging one. How about log base 2? Are you ready? 1/4. Log base 2 of 1/4. Ariel, what do you think? Oh, look at you show off. Why is it 1/2?
Because 1/2 squared is 1/4.
Okay, let's look at the definition. Right, so log base b of x equals y. So b is my base, right? So b to the y equals x. So b is my base. What's my base here? 2. So 2 to something to the y equals 1/4. So you said 1/2 squared, right? So what's the problem with that? What's my base? 2. So if I did 1/2 squared, what's my base? 1/2. So do we have a problem, Houston? So what do you think? What do you think? What do you think? What do you think? Okay, so I need, oops, I didn't mean to erase that. I need 2 to some power equals 1/4. Well, let me rethink this here. I've got 2 to some power. Can I rewrite this 4 as 2 squared? Okay, so now I have 2 to some power equals 2. How can I rewrite this 1/2 squared? Alex, how can I rewrite the 1/2 squared without using a fraction?
I'm not sure.
Jesse, have an idea? Morgan? Jordan? Ava? Isabel? Almost. What do I do? How do I move this up here? Jackie? -2. Good. 1 over 2 squared. If we move it up, remember our properties of exponents, right? That's -2. So now I have 2 to the power of y equals 2 to the -2. So what does y equal? -2. Y equals -2. So let's go back to this now. 2 to the power of y. So 2 to the -2 equals 1/4. Are we okay with that? So what does log base 2 of 1/4 equal? -2. There you go. Good job, Gavin. -2. So we just, all of a sudden, right, we're like, I get it. I get it. Yeah, I'm bored. This is so easy. I get it. And then all of a sudden, I don't get it. Right? But we can do it, right? The idea here, and then we're going to use this when we're solving exponential equations. The idea here is that if I can get the same base on both sides of the equal sign, that I can set the exponents equal. Do you remember when we were solving the half-life word problems? Right? And on the half-life word problems, that's exactly what we did. Remember I told you get the same base on both sides? If you've got the same base on both sides, at that point, because we hadn't learned about solving exponential equations or logarithms, I just told you if we have the same base, ignore the base, and then just set the exponents equal. Does everybody remember doing that? Just nod your head so that I feel like you remember. Thank you, Emily. Okay, just pretend, all right? So that's the idea. When we're solving exponential equations, if we can get the bases the same, then we can just set the exponents equal, okay? That's going to help us in solving these logarithmic equations, right? Okay, let's do another one. How about log base 3 of 1 over 81? Log base 3 of 1 over 81. I'm going to give you a moment to try and think that through. Okay. Let's see here. Did you get it? What'd you get?
Log base 3
Equals -4. Yes. Excellent. Caleb, how do we know that that's true? No idea. Okay. Mika, how do we know it's true?
Well, what I did is I did 3 times 3 times 3, which is 3 times 3 times 3 times 3, which is 81.
So 3 to the, if it's 3 times 3 times 3 times 3, how could we write that more efficiently? 3 to the 4th. And that equals 81, right? So how'd we get?
Since it's a fraction, I just flipped it to the
Very good. Yeah, since it's a fraction, since the 81 is in the bottom, right, Caleb? 81's in the bottom. We're going to make this 3 to the -4th equals 1 over 81. So that means our log base 3 of 1 over 81 equals -4. Okay? Okay, let's keep going. Because I'm just feeling so much energy. This is so exciting. Okay. How about log base 3 of 1? Log base 3 of 1. Log base 3 of 1. Isabella. 0, yes. How do I know that that's true? 3 to the power of 0 equals 1. Very good. Okay, Ariel, how about log base 10 of 1? Still beat it to 0, yes. Okay, let's turn to our formulas page because here's your next property, right? We have the definition that I already gave you. So the first property says that log base b of 1, so it doesn't matter what the base is. It could be 3, it could be 10, it could be 5 billion. It doesn't matter what the base is. Log base b of 1 will always equal 0. Because, I'm going to use abbreviations, right? Because b to the 0 equals 1. So there's our first property. We have our definition. Now we have a property. Okay? Okay. Let's look at another one. How about log base 4 of 4? Log base 4 of 4. Gavin. So what is log base 4 of 4? 1, right. Log base 4 of 4 is 1 because 4 to the first equals 4. Okay. Alex, what is log, oops, that's not an L. What is log base 8 of 8? 1. Why? 8 to the first equals 8. So we have our next property. Property number 2. What do you think that's going to say? Log base b of b equals 1. Because b to the first equals b. Right? So property number 2, log base b of b equals 1. Okay, we good so far? These are kind of common sense, but then all of a sudden we're going to jump up to a little bit harder. Let's say that we have log base 3 of 3 squared. What do you think? So remember our definition. Our definition said if the log base b of x is equal to y, then b to the y equals x. That's our definition, right? That's our definition. Well, if I look at this, what's my b? 3. So we've got 3 to the y. So y is what I'm trying to find, right? Y is right here. So we're going to leave that as a y equals x. Now what's x? 3 squared. Okay. What does y equal? Y equals 2. Okay. Let's look at another example. Let's look at log base 8 of 8 to the 4th. Okay. So let's use our definition to put it in exponential form. So we've got b, and what's b? 8 to the power of y equals x, and what's x? 8 to the 4th. So what does y equal? 4. Okay. Now, this time, I want you to tell me what log base 10 of 10 to the third equals without going through all that work. 3. How'd you know that? Yeah, it's just that exponent, right? Look at what we're seeing here, right? This equals 2. This one equals 4. This one equals 3. So we just discovered our next property, property number 3. Okay. Property number 3. Log base b of b to the y equals what? Y. Because, right, if I use my exponential form, b to the y equals b to the y. That seems obvious, but it only seems obvious now because we know it, right? Okay. So that actually is going to be a very valuable property and save us a lot of work, okay? Okay, the next one. Now this one is a little challenging. Use a phrase you guys like. I'm not going to lie to you. I always love it when people say that. I'm like, well, thank you. Appreciate you not lying to me. As though that's like your normal practice. I'm not going to lie to you, Mrs. Murray. Okay, so let's look at this. We've got, let's do 3 to the power of log base 3 of 9. Okay, let's just explore this for a moment. What is log base 3 of 9? 2, because 3 squared is 9. So that means we have 3 to the second. Now what is 3 to the second? 9. Okay, how about 5 to the log base 5 of 25? Okay, 5 squared is 25, so that means log base 5 of 25 is, okay. So Gavin, you are going to the right place. Your brain is going there, right? You're retrieving the information. You're getting the correct information, but you're saying it incorrectly, right? Yes. Log base 5 of 25, and you keep saying 5 squared, right? Because your brain is going 5 squared equals 25. So you're locking in on this, right? But by my definition, do I still have it up here? No, of course I erased it. My definition says log base b of y equals x if and only if b to the x equals y, right? I'm looking for the x, not the b to the x. So when your brain goes 5 squared, that's telling me that the x is 2. So this log base 5 of 25 is 2. Okay? So your brain is so far ahead, you're getting there, but if you're going to be able to write your answers down in a way that I can understand what you're doing, you need to make sure you go back and you fill that in the correct way, right? So this log base 5 of 25 is 2. So now I have 5 to the second, which equals 25. Okay? Okay, let's do another one. Remember, when you justify your answer, okay, that's how we phrase it. When we justify our answer, we're using the definition or the properties, okay? So if I have 27 log base 27 of 3, Based on the previous examples, what's that going to equal? Look at the previous examples. 3 to the power of log base 3 of 9 equals 9. 5 to the power of log base 5 of 25 equals 25. So what does 27 to the power of log base 27 of 3 equal? 3. 3. Right? It always equals this number right here. Okay? So let's look at what's actually happening here based on our definition. Because this one gets a little tricky. If you look at this form, this is not a logarithmic form, this is an exponential form. So this means that I have b to the y equals x. Right? That's exponential form. According to my definition, it was an if and only if, which means it goes both ways, right? We're going both ways. So according to my definition, this implies that log base b of x equals y. That's what my definition states, that log base b of x equals y. Sometimes I switch my x and y, so I'm just double checking that I'm using the same notation. Okay, well, let's look at what we have. In this example that we just did, what does b equal? 27. What does y equal? Nope, b to the y. So this part right here, this is my y. Okay, so that would be log base 27 of 3. That's my y. What does x equal? 3. Okay, now let's take this information and let's plug it in up there. So that would be log base 27 of 3, x is 3, equals y. What does y equal? Log base 27 of 3. Is this true? Sure it is. I've got the exact same thing on the left and the right. So of course it's true, right? So if you look at this, right, this starts out in exponential form, but according to my definition, so my justification, according to my definition, I end up with the same log on both sides. That leads us to our next property, property number 4. Property number 4. And that's going to say b to the power of log base b of x. Thank you. Bye-bye. B to the power of log base b of x. This equals, what is this going to equal? X. It equals x because log base b of x equals log base b of x. It sounds so silly to say that, but that's how it works out when I plug it back into the definition of my logarithm. Okay? So those are 4 properties plus a definition. We will be adding to those properties. But for right now, I'm going to have you do a practice worksheet just evaluating the logarithms. Okay. Now, when we do this worksheet, let me hand it out first and then I'll explain. Okay. Some of you, especially people with brains like Gavin, right? You're going to look at this and you're going to know the answer. But I don't want to just see the answer. I want to see the justification. So for instance, right? So for instance, number 1 says log base 7 of 1. Do we know the answer to that? What is it? 0, right? But I don't want to just see the answer. I want to see your work. You're going to show your work by justifying it, because 7 to the 0 equals 1. There's your work or your justification. Okay? So I'm going to give you a few minutes to do this, and we should have time to go over it. And I'll give you your homework worksheet. Okay? So number 1, we just did that. Log base 7 of 1 equals 0, because 7 to the 0 equals 1. Okay? Number 2, I think this was one of our examples. Log base 5 of 125. What does that equal? 3, because 5 to the 3rd equals 125. Number 3, log base 2 of 16 equals 4, because 2 to the 4th equals 16. We good so far? Okay, here's the hard one. Log base 6 of 216. Who's got that? Jackie. 3, yes. Because 6 to the 3rd equals 216. Okay, number 5. Log base 4 of 64. What does that equal? 3, because 4 to the 3rd equals 64. Okay, number 6. Log base 3 of 9. We know that equals 2, because 3 squared equals 9. Log base 3 of 1. Allie, what does that equal? Why? Yes, 3 to the 0 equals 1. Gabriella, log base 3 of 243. What is that? 5. Why is that? Yes, 3 to the 5th equals 243. Alex, log base 7 of 343.
3.
Why is that?
7 to the 3rd equals 3.
There you go. 7 to the 3rd equals 343. And then, Annalie, how about log base 2 of 4?
2
Because?
to the power of 2.
There you go. Excellent. Okay. Any question on that worksheet? Okay. I have a homework worksheet for you. Again, I'm going to explain just a couple of problems. You remember homework worksheets? We're expecting what? A homework mini quiz the next day of class, which is tomorrow. Okay. So on the homework, of course, you can see the first couple problems are a little bit harder because we've got some fractions in there. The first section, 1 to 3, says rewrite in exponential form. You're not solving anything because I've already given you the answers. You're writing it as an exponent, okay, which is what we did when we did our justification. That's exponential form. Okay, this is exponential form. And then the next section says to rewrite it in logarithmic form, right? So this is logarithmic form. And then the bottom part, you're evaluating it. Yes. Absolutely. Yeah. Okay.